Okay, you can start go. Now, so after the integers, we still have what we call rational numbers and irrational numbers. We talk about the natural numbers. We say that one is just like a counting of numbers, and we take it to be positive. And then we have what we call the integer. We say integers. It's just like the extension of our natural numbers. So the next one we have is our rational numbers and irrational numbers. So when we are talking about rational numbers are those numbers that can be expressed in the form of let's say P over Q, where P and Q are elements of integers and Q is not equal to 0. So when we are talking about the rational numbers, are those numbers that can be expressed in the form of P over Q in the ratio, where that P and Q will be an integer. We have already talked about the integers, the properties that guide them. So where that P and Q will be an element of integers and Q must not be equal to 0. So when we can express the number in form of this, we call it a rational number. So if the number cannot be expressed in the form of P over Q, that one is a irrational numbers. And each of them have its own symbol. So we use rational number is denoted by, we are going to bring more examples so that you can see how we can differentiate between the rational and irrational. So rational numbers is denoted by Q. Now, for example, what are they trying to say? Or what are we trying to talk about here? Let's say, for example, if I take 5 and 6, for example, 5 and 6, they are element of integers, right? So if I can express them in the form of 5 over 6 in the form of ratio, so of course, it's said to be rational numbers. So this rational number too also involve what we call a perfect square. What is a perfect square? Are those numbers that we can find their square root, like for example, if I have square root of 4, square root of 4 is known as what? Yeah, good. Square root of 4 is known as 2. If I have square root of 9, that one is known as what? Exactly, it's 3. So when we have square root of 16, that one is 4, and so on like that. So all those ones that have the perfect square root, we can also include them under the rational number. While all those that doesn't involve a perfect square root are called irrational. For example, if I have square root of 3, you can see 3, it is very difficult for us to have. If you press the square root of 3, it's going to give you a decimal number. So that one is irrational. So like all this, for example, let's say we have square root of 9 over 4. We are asked that if this is a rational numbers or irrational. I know if I have this, it's nothing but square root of 9 over square root of 4. So what is the square root of 9? Yes, exactly. That square root of 9 is 3. And the square root of 4 is also known as 2. Yes, good. So now we can see we are able to express the square root of 9 over 4 in the ratio of 3 over 2. So we know that where 3 and 2, they are element of integers. But for example, let's say I have, even if it's just a number, let's say I have square root of 25. Of course, if I have 25, I can rewrite it as a square root of 25 over 1. I can find the square root of 25. At the same time, I can find the square root of 1, meaning this is nothing but square root of 25 divided by square root of 1. So we know the square root of 25 is nothing but what? Yeah, exactly. Good. That means you are following. So the square root of 25 is going to be equal to 5, and the square root of 1 is going to be equal to 1. So now we are able to express 25 in the ratio of 5 over 1. So why are they saying it must not be equal to 0? It means if it is equal to 0, it can make the problem to be undefined. For example, let's say we have 6 over 0, for example. 6 is an integer. at the same time is also an integer. But if you press this, if you use your calculator, it will be showing you either syntax error or math error. So that's what you're trying to avoid here. So the number must be 0. Now, if I take a look at this 25, for example, we have square root of 25 over 1. So we split them into 2. That's a square root of 25 over square root of 1. So now we know the square root of 25 is nothing but 5. And the square root of 1 is nothing but 1. So which means we are able to express this one to be in form of 2 integers. That is a 5 and 1 element of integer. So of course, this one is a good example of rational numbers. But let's take another one. Let's take like 7 over 2, for example. Which is this one is a perfect square. But let's take square root of 7 over 2, for example. Can we find, if I express this, I know this is nothing but square root of 7 over square root of 2. So I can write this one here, that this one is a rational numbers, which is divided by capital Q. Now, if I look at this, if I have square root of 7 over 2, that one can be expressed as a square root of 7 over square root of 2. Can we find, do we have a perfect square for 7? Does 7 have a perfect root? Yes, of course. If you press the calculator, you see that we are going to have a decimal point. So meaning we cannot express this value in the ratio of P over Q. So that means this one is a good example of what? Of irrational numbers. So that's the difference between rational and irrational. Very simple and straightforward. Once you are able to understand what we call natural number, I've already discussed the natural number and some properties. The natural number is just like the counting of numbers. And we talk about the integers, it's just like the extension of the natural numbers. And when you're talking about rational number and irrational, the only difference between them that for the rational number, it can be expressed in the ratio of P over Q, where this P and Q are element of integer. Or to not confuse you, I can even use another alphabet. Maybe we use, let's say we use A and B. Since we say that rational number can be denoted by capital Q, maybe where in the form of A over B, where A and B are element of integer. So when we can express a number in the form of this ratio, and where that B is not equal to 0, so we said that number is called a rational number. But if it cannot be expressed in the form of in this form, so that one is said to be irrational. So we can have many examples like, so that means rational number involve or include the perfect square. Like for example, maybe they said determine, let's take a look at this. Maybe they said determine, maybe I was asked to determine this. Maybe they said determine, maybe you are given a problem like this, 100 over, let's say we have 16, and we are asked to determine if it is rational numbers or irrational numbers. So now, as I told you, this can be written as square root of 100 over square root of 16, isn't it? Now we know what is square root of 100. Yeah, so the two numbers that we can multiply to get 100, we know that one is 10, and for this one too is 4, right? So now, if we can even reduce these fractions, even without reducing it, we can see that we are able to express the number in form of ratio. So here I can have 5 here, 2 here is 5, 2 here is 2. These are 5 over 2. So clearly, both 5 and 2 are element of integer. So of course, this is said to be what? It's said to be rational numbers. So if you can find the numbers and you see that you cannot express it in form of ratio like this, maybe we have square root of 15 all over 7. Does 15 have a perfect square root? Yes, of course, no. So that means this is nothing but square root of 15 over square root of 7. So this and this cannot be expressed in form of a ratio. So of course, this is said to be, so here I can see this one is an element of rational number. So this one is said to be a rational number. So that's the only difference between the rational and